Hi, is this working? Yes. So very happy to be here, literally breaking the ice for this conference. Um, so this conference, in a typical Montreal way, will be in Franglish. There are slides in French, others in English, and it's the result of me playing with slides so often that I sometimes lose track of what's in the conference. But Al Gore does the same, so why not me? Again, I'm doing this with my double hat of Chair of Climate Reality Project for Canada and also Director for David Suzuki Foundation in Quebec and the Atlantic. I'd like to start with that picture of the Earth that was taken. It's one of the first pictures of the Earth. It was taken by Apollo 8 almost 51 years ago this year. I think it was on December 24th. And the reason why I'm starting with this presentation, this picture, is that it's very hard to believe that it's only been 50 years since we actually saw the Earth from space and discovered this planet that we live in. And it was really an eye-opener for many people, definitely for the astronauts on Apollo 8, who said that they went to discover the moon and they came back having discovered the Earth. But it was also a wake-up moment for the whole of mankind to actually, humankind I should say, to actually see the Earth from above. And it started changing our relationship to our planet. This one was taken by one of the last Apollo missions in 1972. That's the year I was born. And the reason why I'm using this picture is it's one of the pictures you've seen most often in your life without actually knowing it, because for about half a century, it was the only picture that we had of a full Earth that was not partially in the shade. And the reason why I'm showing this picture to you is if we were to take the Earth at the size of a basketball, the biosphere, all the living organisms, species on Earth, would be no more than just a thin layer of paint that would put on our basketball. So there are different estimates of the number of species on Earth. I heard 35 million species. Actually, we don't know because it's almost impossible to inventory all the species on Earth. But the thing is, all of these, that great diversity of life on Earth is no more than that thin layer of varnish or paint on our basketball. And it tells you the fragility of life on Earth and how important it is to care about it because we are part of it. That's really, if I was to summarize David Suzuki's career, I could summarize it in one simple message. We are interdependent with nature. Actually, we are nature. This is the Earth atmosphere. Again, another thin layer of different gases. And of course, it's creating the greenhouse effect, which is a good thing, right? Because the Earth atmosphere allows for water to be present in a liquid form, and that's how life emerged on this planet. And so the average temperature, winter, summer, northern hemisphere, southern hemisphere, day and night, if we take the entire planet, the average temperature is about 15 degrees. And so, of course, the greenhouse effect is a good thing because it ensures that we have this climate that we can live in. But of course, we've started changing that, and I want to show you a couple of elements that we need to understand how we're changing our relationship with the rest of our planet or the other species in the biosphere. And the first one is really the growth of human population. So if you look at the numbers here, let's just start from the end of World War II. 1945, 2 billion, just above 2 billion human beings on Earth. And we're now over 7 billion. And we're going to reach 9 billion people somewhere in around 2050. And it's not only a population issue, it's a consumption issue, because one human being today consumes much more than one human being a generation ago or 2 generations ago, and especially in developed countries. And so what's important here is not only to understand that population is a driving factor of our changing relationship with the Earth, but also that we have to multiply each individual by its consumption, and that consumption is growing too, which raises the question, how much is enough? Can we always consume more goods, services, products, or is there a limit to what we can use within a closed system? Because our environment is the biosphere is not is a limited environment. So it asks the questions of the limits to our own growth in population and consumption. We have entered the 6th massive extinction of species in the history of this planet. The last one is the one that you guys all know. It's when the dinosaurs disappeared, the Jurassic Park period, 65 million years ago. But this time it's different. It's not a huge catastrophe that's destroying species or a change in the Earth's orbit or something like of a astronomical scale. What's actually causing this extinction is the fact that our species is taking too much of nature's space and resources, and basically we're taking it away from other species. We're taking habitats away by destroying forests, or we're, for example, the fishing, commercial fishing has depleted most of commercial fisheries in the world, and so the oceans are depleting too. I don't have to tell you the story, you know it, but it's important to understand that it's us occupying too much space in the biosphere that's actually taking away and destroying other species. And of course, the last but not least of the way we're changing our relationship with the biosphere is climate change. And so this is the most complex graph in my entire presentation, and it's not that complex. I tried it on kids like 4 years old, and they said, yeah, sure, the two lines go together, but some people, including the President of the United States, still deny that the 2 lines go together. But I mean, a 4-year-old can tell you. So what you have here is in white is the temperatures, global temperatures in the past 800,000 years, and in blue is the CO2 concentration in the atmosphere over the same period. And very quickly you can see that when CO2 goes up, temperature goes up, and when CO2 goes down, temperature goes down. And the difference between here and here is 2 kilometers of ice over our heads. So basically, if we take CO2 concentrations from about 280 parts per million, and when they drop to 180 parts per million, we end up in an ice age. So where are we today? Where are we today? All right. So that's the beginning of the Industrial Revolution, and that's where we are in 2019. So if I'm telling you from here to here, it's an ice age, from here to here, that can't be good. And we've never experienced, as a species, we've never experienced a world where CO2 concentrations are at above 400 parts per million. And that's a very important thing to know and to understand, because everything we've built, like our civilization, our very complex societies, have been developed over the past 11,000 years or so, based on a pretty stable climate. And now it's changing. And what if we do nothing? What if we continue burning fossil fuels for another 50 years, 40 years? That's where we end up. And the problem is when we're here, no scientist is willing to tell us that our civilization and even our species can survive, can thrive in this world. It's like jumping off a cliff and hoping that there's some parachute in our bag. It's really a jump in the unknown. Of course, we understand more and more what it means because our science is evolving. But definitely, it means a world that's much more hostile to us than the world we live in now. And of course, the problem comes from the burning of fossil fuels that are oil, gas, and coal. And we call them fossil fuels because they are fossils, actually. They are sorry, I'm trying to find the words in English here. It's past life that essentially is in the ground, and there's carbon stored in it. And when we burn this, we throw the carbon back into the atmosphere, and that's how we're warming the planet. And here's the problem. So we learned about climate change about here. We had proof that climate change was happening, it was real, caused by human beings. About here, we could have gone this way. But instead, we went this way. And now we're forced to go much more on a steeper decline on our consumption of fossil fuels. And it's really like the cost of losing the past 30 years is really hitting us now when we have to adapt to climate change at the same time as we need to reduce our greenhouse gas emissions. And of course, greenhouse gas, fossil fuels are everywhere in our society. They come from almost like anything that's related to transportation, the heating of building, producing electricity. Basically, we need to find solutions to all of this in the next 30 years. And we need also to stop burning forests because about 20% of climate change is linked to deforestation. So that's one of the numbers. I'm sorry, I'm going to keep hitting you with numbers and like that, just like that are hard to just deal with. And this is one of the that's really hitting me. So CO2 right now is released into the atmosphere at the fastest pace in 66 million years. So the last time there was so much CO2 going in the atmosphere, dinosaurs were living on this planet. Just to give you a hint, like our species appeared about 200,000 years ago. And we invented agriculture and the first civilization 11,000 years ago. We're talking 60 million years ago. And the energy that's trapped by our CO2 emissions is equivalent every day to 500,000 Hiroshima atomic bombs. So the first time I saw this, I went like, oh my God. And the number was 400,000. But then our emissions grew, and so we're now at 500,000 Hiroshima bomb every day in terms of the, I just want to make sure you guys are all awake. So 500 times per day. That's a lot of heat. And sometimes some people will tell you, yeah, of course, but these are only models, scientists in their labs predicting global warming, but global warming is not happening for real. We have 4 different series of data that show warming, 2 from the US, 1 from the UK, and 1 from Japan. And sometimes you're going to hear, yeah, of course, but warming stopped in 1998. Because 1998 was a very, very hot year. And then, you see the difference. So if you take 1998 as the basis of your study, well, of course, the Earth is not warming, it's cooling. But if you take 1997, it's warming. So we have to be careful. There's there's a lot of disinformation taking place. It's not denial. It's not climate denial. It's climate disinformation. It's happening on purpose. And so the real trend here is an accelerating warming trend. And you can see it on this graph that was, not graph, but this animation that was prepared by NASA. And you're going to see there are cooling and warming periods, but look at what happens in the 80s, the 90s, 2000, and today. So warming is happening, it's accelerating. 18 of the 19 hottest years on record have occurred since 2001. And like the only one that was before that is 1998. Again, that was a very hot year. The hottest of all have been the last 5 years. So we're breaking records every year now. 2018 was the 42nd consecutive year, where the average temperature was above the 20th century's average. And September 2019 was the 415th consecutive month above average. So if you have an average, you have a quarter and you play with a quarter, you're going to get heads and tails half and half, right? And that's how you get 50-50 average. So normally for temperatures, you should have half that's above average and half that's under average. Now we've had 415 consecutive months above average. So we've entered a new normal, or something's wrong with our quarter. And July was the hottest month in history, but I think I saw last week that October was the hottest month in history. So again, we're breaking records every month because this warming trend is accelerating. And we've entered an era of consequences, and we see it, as Michel said, for the wine industry. We've seen it here in Montreal with floods, not 2 years in a row, but 2 out of 3 years, major floods, historical floods in Montreal. And the year in between those floods, 2 people died because of heat waves here in the city. I could get you examples of Australia, in the US, the Western Canada, where in British Columbia, forest fires were, again, of a historical scale for a few years. We're just hitting the beginning of those consequences. And so we're now forced to win this kind of climate battle, not only by reducing greenhouse gas emissions as fast as we can, but also we need to adapt what we do because the past is no longer can no longer predict the future in terms of our weather and climate patterns. And this is why countries in the world signed the Paris Agreement in 2015. It's the first international agreement ever that was signed by all countries in the world. Now, of course, the US wants to get away from it, but negotiators were very clever. There's another US election before the US can actually pull out of the Paris Agreement. So the next US election will actually decide whether the US is or not in the Paris Agreement. That agreement essentially says that we need to reduce greenhouse gas emissions in the world to avoid warming superior to 1.5 to 2 degrees. And it seems like these numbers seem very small compared to the 60 million years I gave you earlier, but the difference between 1.5 and 2 degrees of warming on this planet is huge. Right now we're above 1 degree. I think we're reaching 1.1 degree in warming already. So it's a huge undertaking, essentially on the scale of a wartime mobilization that needs to happen if we're going to succeed. What the GIEC in French, or IPCC, the International Panel on Climate Change, what the IPCC says is we need to reduce our pollution by half globally by 2030. And you've seen the graph earlier, it's still rising. It's not falling yet. And we need to be entirely zero emission by 2050. It's important because if you build infrastructure, energy infrastructure today, you're not building infrastructure for the next 5 or 10 years. When you build a power plant, it's for 40 years. When you build a pipeline, it's for 40 years. If you discover new oil deposits, you're going to exploit them probably for 25, 30, 40 years. So the decisions that are being made in the coming years are critical because they actually lock in greenhouse gas emissions or take out greenhouse gas emissions for decades into the future. And so what I'm trying to tell you here is some people say that scientists or environmentalists or young people are alarmist because they basically tell it the way it is. And so the climate emergency is real. It's not a matter of opinion. It's a matter of mathematics. It's just like there's a certain amount of carbon that we can still put into the atmosphere, throw into the atmosphere, before we hit 1.5 or 2 degrees of heating. It's just like a very simple, it's complex equation, but it's simple mathematics to understand. The more you put into the atmosphere, the warmer it gets. And so there's a limit at some point. So when the IPCC released its report in October of 2018, a year ago, we had 12 years left of carbon budget. And now we have 8 years left of carbon budget because we spent so much in the past year or so. So again, we're really entering critical years, and that's why people are getting more alarmist. And if your house is on fire, ringing the alarm bell is the thing to do. Sometimes alarm is the right thing to do. And I think this time our choices will have a decisive effect for the coming years, but also for the coming generations. It's because we're reaching a point of no return from which, of course, there's no turning back. But there's also a lot of good reasons for hope, and it's not only wishful thinking. It's just things are happening right now. So this is global wind energy capacity from 1980 to the present. I'm just showing you these graphs so that you have a sense of we're entering exponential growth in several of the technologies that need to replace fossil fuels. It's happening at the same time. It's happening very fast. And so we're catching up because we lost 30 years, but we're catching up very quickly. This is world solar photovoltaic installations. Again, like solar energy right now in the southern United States is at around 3 cents per kilowatt hour. Wind energy in Alberta is now around 4 cents per kilowatt hour. Hydropower in Quebec is at 8 or 9 cents per kilowatt hour. So so eventually, because the cost of renewables is falling and the cost of new fossil fuel reserves is growing, eventually there's a point where it's no longer economically viable to exploit fossil fuels. And that's just happening. Global electric cars on the road. It's taking a little more time because batteries are also part of the equation. The cost of battery is falling and their capacity is improving. It's like our microchips in our computers. Like microchips are becoming more performant and cheaper every 18 months or so. It doesn't stop because we're improving all the time. Same thing can happen with batteries, electric cars, and also renewables. And so it takes time, right, to change our entire energy infrastructure and to change our entire road system, to go from fossil fuel cars to electric cars. And sometimes it's easy to essentially say, it's not going to happen, it's going to take too long, we're not going to get there on time. But I like this picture. This is Easter morning in 1900 on Fifth Avenue, New York City. There's one automobile And then the rest are comment on dit des calèches? Carriages. Thank you. So basically, horses and carriages have been the main way human beings essentially moved around for what? Thousands of years? So when we introduced the combustion engine in the car, it took only 13 years in New York to replace all carriages. So imagine, so you would go from horses to sitting on on gasoline with like an engine that was like not necessarily very working all the time. So what we're trying to do today is going from a combustion engine to an electric engine, but it's still the same car. So the change could happen very quickly too, because we're not actually changing that much the way we do things. Same thing for electricity. Like, I'm sure you don't mind whether your electricity comes from, like, when you turn on the light, if it comes from solar, it's just good. You're not changing from lighting your house with oil to electricity. We use electricity. It's just the source of electricity that's changing. So basically, the changes that are being asked from us, like, will demand a lot of changes in our behaviors. That's for sure. I'm not saying there won't be important changes. What I'm saying is change can happen very fast, because a lot of the changes we need to make will not necessarily be as huge as changes we've seen in the past, and that happen very quickly. And also the other thing that gives me hope is the fact that it has become the largest grassroots citizens movement in the history of this planet. On September 20th to September 27th, there was this climate strike week across the world. 7.6 million people marched in the streets or went on strike in 170 countries in this world. And that's new, right? That's a scale that we had never seen before. And here in Canada, we saw people marching in the street. I'm sure you all know people who actually went in a demonstration for the first time in their lives. A friend of mine is a police officer in a small town called Rimouski, east of Quebec. We grew up together, and he wrote to me, he was so proud. He wrote to me, I took part in my first demonstration. And he did it basically because this is becoming a moral issue. It's becoming an issue of protecting life on this planet and also protecting our children. Protecting polar bears and ice is something, people will care about, but protecting my kids is something I will really care about. And so this is in that context that Greta Thunberg was here in Montreal, and David Suzuki Foundation and others organized this rally. Quite frankly, I had never seen something like this. And it was it gave us a lot of hope. But again, Greta's message is strong because she says things the way they are, and she's young. And this is becoming a youth movement, and I think we need to listen to them. And earlier I talked about like a wartime mobilization, or if you want to see it in a less warlike fashion, it's a new moonshot. It's a race to the moon. In the 1960s, at some point, the U.S. was spending 4% of their GDP on the Apollo program. 4% not of government budget, 4% of GDP, of the entire wealth of the country. So this is something, if we have the political will, we can do this. And as Al Gore says, political will is a renewable resource. And that's all I had to tell you this morning. This is our planet. Again, the biosphere is only that thin layer of life, and we are holding this basketball in our hands. Thank you.
I was just saying it's a pretty scary presentation. I think it's after watching something like this, what do you tell the population? Not to feel paralyzed, but empowered to do something.
Yeah.
Where can they start?
Yeah, I think 20 years ago I would have told you start changing your light bulbs. or do the little things that. But now it's not enough anymore. What we need is collective action. So what I would say is make it a priority everywhere, in your workspace, in your family, in your conversations with your friend. So right now we're reaching critical mass at the same time as we're reaching, I guess, the pivotal moments for like technologies such as solar, batteries, all of these things. So change will accelerate, but people will need to accept that there will be changes. So governments will stop where they hit our wallets or they hit some political resistance. We need to accept the changes, the hard changes and the good changes that we're going to need to make in the next 10 years. So we should all see ourselves as, I guess, accelerators or like people who can accelerate change in our environment. And you know what? Like people won't change their behaviors or they won't accept changes because a guy like me will go on stage and talk blah, 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 or go on TV. People will accept changes because their neighbors, their brothers, their sisters, their wife actually say, or their children especially, will say, this is the way we do things nowadays. And it's going to happen. So don't underestimate your voice. It's not like and don't judge people for making wrong choices. I make like wrong choices every day. But make sure that people understand that for you this is important and that you're embracing this change. And then you're going to change the social norm without actually having to do much more than just being true to your values. That's three concrete actions? Sure. So 3 concrete actions that you can do in your daily life. So I'm depending on where you live, it's different. But if you here in Quebec, our electricity is almost like 99% clean electricity. So in that case, it's your air travel that you should reduce. You should reduce also the use of your car, or move to if you have a big SUV, you should think of a smaller car. If you have a smaller car, you should think of an electric vehicle. And if you don't need a car, you could go to car sharing programs or things like that. And the last thing is your food consumption. The less meat you eat, the less impact you have, and especially for red meat and beef especially. And then a fourth one, that's a bonus, compost. Because there's a lot of greenhouse gas emissions from landfill. So these are the things that we control, right? It's the fossil fuels we're using. If your house is still burning heating oil, you should switch to electricity as soon as you can. My dad still uses heating oil. I'm thinking this is going to be a conflict story this Christmas. That all? All right, thank you very much.